Hello, sir. Am I audible?
Yeah, you're audible. Hello.
Uh, Sir, can you provide the video recorder, please, sir?
Yeah,
The
sure.
recordings of the class.
Whatever now I am doing, I'll provide. Okay.
Yes, sir.
Okay. Okay. Today we'll do the inverse Z transform. Okay. So now, so earlier we have done whenever the input signal x of n is given, we were finding out the x of z. Now, if we have x of z, okay, how to find out? So x of n from this x of z. So in finding out this, so input signal from the Z transform, so we are having the two methods. So to find out the inverse Z transform, that is, one is partial fraction expansion method, okay. One is partial fraction expansion method, another one is power series expansion method. Okay. So now first we will see what is actually partial fraction expansion method, how we can do in this, how to find out the inverse transform of a signal. Okay. Okay. So in this, so now if we have x of z, okay, so it will be having both numerator and denominator in terms of the transfer function, which is, let us take this as b of z and this one as a of z, the numerator and denominator, where it will vary. So the z values, okay, so it will vary from some 0 to m values. Let us take k equal to 0 to m, okay, 0 to m, then so the coefficient bk into z power minus k. Okay. Similarly, in the denominator, so k equal to 0 to n. Okay. So let us take ak into z power minus k. Okay. So where bk and ak are the coefficients, they are varying. So let us take, so if we expand this summation, it may look like this: b naught plus b1 into z power minus 1 plus b2 into z power minus 2 plus up to, so the m values, that is.
Sir, your voice is too low, sir.
Is it okay? So volume is high only, I don't know what is the problem. Now is it fine?
Yes, sir.
Okay. Okay, so bm into z power minus m. Now similarly in the denominator, so we have, so a naught plus a1 into z power minus 1 plus a2 into z power minus 2 plus up to go on, so till the value of n, so that is a n into z power minus n. So now, so here we are considering for the denominator, which is a naught equal to 1. Okay, the coefficient where a naught equal to 1 we are considering in the denominator. Okay. So now this partial fraction we can directly, so get the solution, provided, so there is a condition, that is, what are the condition is that if m is less than n, that is the power of the numerator, so the maximum power of the numerator m which is less than n, so then we can directly factorize and we can able to get the, so inverse Z transform. Or if m is greater than n, that is in the second case, so the first case m is less than n, so here directly we can obtain the Z transform. Obtain Z inverse Z transform using the partial fractions. There is no like extra thing we need to do. So directly we can obtain the inverse Z transform using partial fraction. So directly we can factorize the denominator and we can able to get the inverse Z transform. In the second case, if m is greater than or equal to n, okay, both the powers in the numerator and denominator, if it is equal, or the numerator power is greater than the power of the denominator, then what we have to do? We have to go for the division method, that is long division method. Long division method. So what we will do here is we will go on dividing the numerator by denominator until the power of the numerator should become less than the power of the denominator, so that we can able to obtain the inverse Z transform. Okay. So that is what we can call it as long division method. So in this we can represent the x of z, which is equal to summation k equal to 0 to m minus n, okay, ck into z power minus k. So this is what the value which will going to get after the division. Okay. So plus the remaining term, that is b dash of z divided by so a dash of z. Okay. So this is so not a dash, so just it is a only, because so the numerator will not denominator will not change. So the numerator power only it will change after dividing. So similar like so whatever we'll do normal division, so we'll divide and the remaining terms it will come, no. So similar like remaining terms will be there in this term, and whatever the division happens, the division number it will be here. Okay. So that we will going to see whenever we solve one problem, we will come to know what is this actually in the number comes along with the z term and then remaining term. So this is long division method. Whenever the power is the numerator power in the transfer function is greater than the denominator power. Okay. So this is the partial fraction. There are two cases we need to solve using the partial fraction expansion method. Okay. So we'll take one problem. So based on both the cases, then we'll try to we'll come to know if any doubts if you got if you get while solving, we can ask. Okay. Now take this one. So the first one problem, x of z is given. The x of z which is equal to minus 1 plus 5 into z inverse divided by so 1 minus 3 by 2 into z power minus 1 plus half into z power minus 2. So now this is the z transform, that is x of z which is given with ROC z which is greater than 1. Okay. So this is the problem. So find the xn, that is find the input signal x of n. Okay. So now we have to find out the inverse Z transform of this. So now you can see here the power of the numerator, which is z, the power of this z term, which is, so here you can see, so it is less than the power of the denominator. Okay. So there is no problem, we can apply directly the factorial form or factorizing the denominator, and we can able to directly get the inverse Z transform. So how to do it? So we can take this x of z, okay, so which is equal to minus 1 plus 5 z inverse divided by 1 minus 3 by 2 into z power minus 1 minus plus 1 by 2 z power minus 2. Okay. Now for the convenience, even we can multiply both numerator and denominator by z square, so that you will going to get minus z square plus 5z divided by 1 minus 3 by 2 z plus, so here z square minus 3 by 2 z plus 1 by 2. So this is what you will going to get. So now we can see, so we can factorize this one. Okay. So we can factorize and you can get it, or else so directly you can factorize this also. Okay, so we can see here, so half into 1, so there is a multiplication factor of half. Okay, and if you add two terms it should come, so 3 by 2. Now you can see half into 1, the multiplication factor will be half only, and if I add half plus 1 it will become minus 3 by 2. So that if I take both the roots as minus half minus 1, so minus half into minus 1, so the factorization it will come multiplication factor, that is 1 by 2, and if I add it will become minus 3 by 2. Okay, so here like this also you can do, take the roots of this and you can get this, and here also so the same thing, z minus half minus z minus 1 it will come. So here also you can do same thing, here also we can do same thing. So I will take this one and I will do it. Okay, so now if I factorize this one, the denominator, we will going to get 1 minus 1 plus 5 z inverse divided by 1 minus 3 by, so I will factorize now. So by taking the roots, of z inverse minus z inverse plus half into z power minus 2. Okay, so now I will take this and this, I will combine, and I will 1 minus z inverse I will combine. So you will going to get 1 minus plus 5 z inverse divided by, so 1 minus z inverse. Okay, so here minus half if I take, so common factor, of z inverse if I take common factor, so here it will having the value 1 minus here z power minus 1. Now from these two factors again 1 minus z inverse is common, minus 1 plus 5 z inverse divided by 1 minus z inverse into 1 minus half into z power minus 1. So these are all the factors we will going to get from this. So the second order, so the denominator, second order equation, quadratic equation. Okay, so now we will get the factors. So now we have to apply the partial fraction. How to apply partial fraction? So you make it the separate the terms in the denominator and equate it this one to the corresponding, so obtain coefficients. So that I will see how we can that we will see how we can do that. That is minus 1 plus 5 z inverse divided by 1 minus z inverse into 1 minus half into z inverse. So this I can divide it as a by 1 minus z inverse. So this is separate factor, and similarly b by 1 minus half into z inverse. So now I am separating the denominator terms. Okay, so this we can equate it like this, and now we can take the LCM of this both the sides. So now we have LCM of this right side, so that we can get 1 minus z inverse into 1 minus half into z inverse. So in this, if you able to find out a and b, so this whole thing we can write it as the term whatever a will going to get coefficient, so that term divided by this, and so the b term be divided by this, and this will be equivalent to this thing. So that is the fractions of this, so that individually we can able to find out the z transform of this one, that is inverse z transform of this. So now if you take the LCM, so we will going to get a into 1 minus 1 by 2 z inverse plus b into 1 minus z inverse. Okay, so now in the denominator we have the same things in the both side, LHS side and RHS side, that will going to cancel each other. So now the corresponding z inverse term we have to equate, and corresponding the without z term we can equate, and we can find out the values of a and b. Okay, so that is minus 1 plus 5 z inverse, which is equal to, so multiply this a inside this, a minus a by 2 into z inverse plus here b minus b into z inverse. Now we can see z inverse terms we can able to so equate it, so that if I equate that we will going to get, so here a plus b, so that a plus b which is equal to the constant term which is equal to minus 1. This is equation number 1. And similarly here, so we can have minus a by 2 minus b. So this is z inverse terms, z inverse term here it is plus 5, we can equate it to plus 5. This is equation number 2. Now we can solve this both the equation to get the values of a and b. Okay, solve these equations and get the a and b values, so that we can able to get the so inverse terms. So I will take this equation here only, that is minus a by 2 minus b which is equal to 5. Okay. So now if I add, so add equation 1 and 2, so we will going to get, so the b will cancel each other, and if I add this one we will going to get a minus a by 2 which is equal to, so minus 1 plus 5 which will be equal to plus 4. So then we will going to get a by 2 which is equal to 4 and a equal to 8. So this is the value of T A. Now if you substitute any one of the equation, so you will going to get the value of b, a plus b equal to minus 1. If I substitute the value of a, you will going to get, so the value of b, b will be going to be minus 9. Now if I substitute this a and b coefficients here, so this corresponding term I can write it as the separate terms with the coefficients a and b, so that we will going to get the so inverse transform. So now we have, so minus 1 plus 5 z inverse, so this divided by 1 minus z inverse into 1 minus half z inverse. This we can write it as a is 8 by 1 minus z inverse plus minus 9 divided by 1 minus half into z inverse. Okay. So now, so this we can take the inverse z transform. Now take inverse z transform, so that we can get, so this term, so 8 into 1 over 1 minus z inverse. So this we already standard result which we have known, so that we can write it as, so 8 into so u of n. Okay. So if you just put u of n, you will going to get the same result. So similarly here minus 9 into, so what is the value here, alpha value which is half into z inverse. So now we will be having a value of alpha which is half power n into u of n. This is what your x of n. Is it understood how to get it? In any step, any doubt? Hello? Anybody?
Sir, explain once again, sir.
So last steps.
This one?
Yes, sir.
So here simply you can, if you take the u of n from n equal to 0 to infinity, that is x of z, if you want to find out for u of n, what will be the thing, u of n into z power minus n, right? Is it not? U of n is 1. So if this is 1,
Yes, sir.
n equal to 0 to infinity 1 into z power minus n. Now this we can rewrite it as n equal to 0 to infinity z power minus 1 into whole power n. Now this is your alpha. Now this we can write it as 1 over 1 minus alpha. So 1 over 1 minus alpha is nothing but this one. The same result we have obtained, right?
Okay.
So you have to be remember earlier z transform values, that is for particular u of n or half power u of n, 3 power u of n, whatever it is. So that results if you know, then you can able to get the inverse z transform, otherwise it will be very difficult. You need to remember those results also, whatever z transform results which we have obtained, that you need to practice and you have to make it sure that you have to remember. So this is how we can able to get the inverse Z transform. So here instead of Z inverse we have so half into Z power minus 1, that is what for this case. Okay. So if I have half into Z inverse here, what will happen? You will going to get 1 minus 1 by 2 into Z inverse, right? Is it not?
Yes. Yes,
Yeah.
sir.
So this is a coefficient which will be remain as it is. So
Same.
A and B. So only for this Z transform pair, that is Z transform factor. So we are taking the inverse Z transform. If I take inverse Z transform for this, you will going to get U of n and half power n into U of n. Is it clear?
Yeah. Yes, sir.
Okay.
Sir, why do we divide and multiply by z square, sir? For what?
No, there if you want to get the factorization, see generally what will happen uh, here, sometimes we won't get the correct proper factorization here. We will confuse with minus 1 and minus 2, how to get factorization. In that case, you can convert it to this known form, that is x square plus bx plus c, like that. In that form you can
Yes, sir.
make it and you can get the factorization. Later you can use that factors here. So in order to make the problem easy, I told this method, that's it. You can directly go for this method itself if you know the factorization perfectly.
Sir, if I go through this method like the positive one,
This also
that
fine,
is square.
this
Yes.
also fine. Finally whenever you get the factorization, after factorization again you have to multiply, so z power minus 2 and get like this partial fraction method.
Okay. Okay. Okay.
That is also fine, but you have to do one more extra step, that's it. Is it clear?
Yes, sir.
Okay. So now try to do this one, another one, so that you can get able to get the practice. X of z, which is equal to 1 by 4 z inverse divided by 1 minus 1 by 2 z inverse, so into 1 minus 1 by 4 z inverse. So now here the factors which is already given, there is no need to factorize again, only you need to do partial fraction. So using partial fraction expansion method, just you have to find out the coefficients and you have to get the inverse Z transform. Try to do it. So
Sir,
here
please open the previous page, sir.
this one. Hello.
Sir, previous.
Still previous. This one.
Yes, sir. Okay, sir. Yeah.
Again, definitely one problem it will come for the inverse Z transform for the examination. if you practice this, definitely you will going to get one question out of the 20 mark question, maybe 10 or 8 marks, or it may be 6 marks depending upon the problem. Okay. Have you done the problem? Anybody got answer? What are the coefficients, A and B values?
Sir, is A is equal to 1.
Okay.
B is
B
equal to
equals to
minus 1.
-1.
Okay.
B
That
is
is,
equal to -1, sir.
yeah. Okay. Fine. A and B equal, A equal to 1, B equal to -1. That is fine. What is the inverse transform? X of n. So we can write this one as A is 1, that is 1 minus half into Z inverse, and B is -1, right? So we can write like this. So now what is inverse Z transform of this? What is for this? It is half power n, right? Earlier we have done, earlier problem itself. Is it not?
Yes, sir. Half power n
Into
u
u
of
of n,
n.
right? So minus here,
Same, sir. Even there also.
yeah,
1 by 4.
1 by 4 power n into u of n. So this is what your input signal x of n for this particular x of z. Clear? So this is also you have to concentrate here. So the ROC is z should be greater than half. Okay. So whenever z is greater than half, that is, so one pole is 1 by 4 here and 1 by 2 is here. Okay. So this is your ROC. For this particular problem, you will going to get the inverse Z transform like this. Now if I change the ROC again, so it will going to change, the problem will going to change. That is, if I take inside of this one, if I take Z is less than something like 1 by 4, now we have, so something like 1 by 4 here and 1 by 2 here. Okay. So now if I take this as the ROC, that is less than 1 by 4, that is Z which is less than 1 by 4, then the problem will change. How it will going to change? So since it is a inside, so the least pole, you have to take negative sided sequence. Okay. So negative sided sequence how we will take? So that I will tell you, and we have to take Z less than 1 by 4. So for the same particular problem, we will going to take Z less than 1 by 4 and we will going to solve. Okay. So if I take the ROC Z less than 1 by 4, so the same partial fraction we will going to get here. So how we will going to get? So we will going to get the plus 1 divided by 1 minus 1 by 2, so Z power minus 1 plus minus 1 divided by 1 minus 1 by 4 Z inverse, we will going to get this one. Now in order to get the signal with ROC less than 1 by 4, less than 1 by 4 means it should be negative sided sequence, that is, so this is 1 by 4 and this somewhere here it is half. Okay. So now inside this ROC means it is less than the 1 by 4 and it should be negative sided. If it is greater than this pole, the maximum pole, then it will be positive sided. Now how to make this one as negative sided sequence and this one? So for that, so we know that, so if this thing is half power n into u of n, so now we can make this as negative sided, so that is half power n into u of minus n minus 1. Now, if I make like this, so the negative sided sequence this one, so then the ROC will be inside. So, that is this signal we can take in the negative sided sequence. So, how to take negative sided sequence? Instead of u of n, earlier problem whatever we did, so now we are taking minus n minus 1, that is negative sided sequence, that is minus of u of minus n minus 1, this is represents the negative sided sequence. Similarly, here for this one it will be equal to, so 1 by 4 power n into u of minus n minus 1. Okay. So, this is how we can able to get the negative sided sequences. Is it clear or any doubt in this? Hello.
So can you explain again, sir?
Here for, as I said, so since the ROC earlier case that is greater than half, so greater than half in the sense, so this is the maximum pole, right. So, the ROC will be outside of this one. So, if the ROC is right sided sequence, as we have discussed in the properties of ROC, it should be, so the ROC region, if it is right sided sequence, if it is then it will be the region, it will be greater than the highest the pole value. So, now here highest pole value we have half. Okay. So, if it is a right sided sequence, it is a greater than the highest pole region, that is, so that is the ROC. So, since in our case, so ROC is given z greater than half in the earlier case. So, that is why we can consider that as a right sided sequence. Is it clear that one?
Yes, sir. Yes, sir.
Yeah, if you go through the properties of ROC, we will come to know. As we have discussed, if the ROC is, the region is greater than the highest pole, okay, then we have the sequence which is right sided sequence. Now, similarly, if we have the region, that is region of convergence ROC less than the least pole, the least value of the pole, then it will be a left sided sequence. Okay. So, in this case what will happen, the ROC will be less than 1 by 4 means this is the least value of the pole, right, 1 by 4. So, then the region is less than this, so that, so the given ROC is less than the least pole value, so that the given sequence should be always, it should be left sided sequence. Okay. So, that is why whatever the value you will going to get from this, you should put the left sided sequence. Is it clear or not?
Yes, sir. Yes, sir.
Okay. So, that is how you will going to get. So, here since B is minus 1, sorry, here B is minus 1, right. So, you have to give here minus. Okay. So, now we will get the left sided sequence for this, and this one the coefficient is minus 1, the left sided sequence for this is u of n minus n minus 1. So, now is it clear?
Yes, sir.
So, any doubt in this? Using the properties you should know, so where to put left sided sequence and where to put right sided sequence. Is it clear in this problem? Any doubt? Hello? Hello? Is it clear?
Yes, sir.
Sir. Yes, sir.
Now the another case, if Z is bounded between 1 by 4 and 1 by 2, what will happen? If the ROC given the same problem, if it is bounded between 1 by 4 and 1 by 2, what we will going to get?
One by 2 power n into u power u of n.
See which is the right sided sequence, which is the left sided sequence.
From minus 1 by
Right.
2 whole power n into u of minus n minus 1.
Yeah, okay.
then minus 1 by 4 whole power n into u of n.
Yeah, that is correct. Because so if you take the largest value of the pole, it should be left sided sequence. The region you can see, it should be for this pole, it is a left sided sequence, but for 1 by 4 it is a right sided sequence, is it not? Is it understood?
Yes, sir. Yes, sir.
Yeah, for the pole 1 by 4 it is the right sided sequence, region of convergence it is in right side. So, that is why it is 1 by 4 power n into u of n it will come for that particular factor. Okay. For the half it is a left sided sequence. So, that is why it will come. So, half power n into u of minus n minus 1, like that it will come. Is it clear? Hello, is it clear for this?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So, now you try to do this one, next one. So, based on the ROC you need to be care whether it is left sided or right sided and try to solve accordingly. Sorry. Now, take this x of z which is equal to 1 plus 2 z inverse plus z power minus 2 and 1 minus 3 by 2 z inverse plus 1 by 2 z power minus 2. Now, what will happen in this case? So, since the numerator and denominator powers are equal, okay. So, since they are equal, so then we have to use the long division method. Here both m and n which are equal, the numerator power and denominator power. So, what we have to do? We have to divide. So, using long division method we have to use, then we have to get the factors. Okay. How to get it? So, now first divide the numerator by denominator, 1 plus 2 z inverse plus z power minus 2. So, take this and 1 minus 3 by 2 z inverse plus half into z power minus 2. Okay. So, now divide this one. So, how many times it will going to divide, so that you see, then we can able to get the factor. So, now we need to cancel this z power minus 2, okay, because it should be this is equal in both numerator and denominator. So, if we cancel this one, then only we will going to get reduced power. Now, we can see here half power z power minus 2 is there and here z power minus 2 is there. So, what is the factor? So, you need to take factor, it is 2. So, now if I take that factor and multiply this, so you will going to get the resultant. Now, if I take this and multiply 2 into 1 2, then minus 2 into 3 by 2 which will give 3 into z inverse plus 2 into half z power minus 2 which will going to give z power minus 2. Now, if I subtract these values, okay, so you will going to get the reduced power, that is, so this will going to cancel each other, then what will happen? 1 minus 2 is minus 1 and plus both will get plus 5 z inverse. Okay. So, now what is the value? So, we will going to get the reduced power in the numerator, which is minus 1 plus 5 z inverse. Now, we can write this one the same whatever it is. So, 2 plus minus 1 plus 5 z inverse divided by 1 minus 3 by 2 z inverse plus half into z power minus 2. So, now you can multiply this and you can take the LCM, it will again become the same thing. Now, we have get the other factor which is extra here. So, that extra term which we have sorry it represented here, you can see here. So, this is the extra factor which we have after division. So, that factor it will going to appear here. So, that is factor. Now, we are getting the extra term which is 2. Okay. So, now this we have already done. So the same problem which we have solved here, the partial fraction, you will going to get a and b and inverse one. So then we can represent that one 2 plus 8 into u of n plus or minus 9 into half power n into u of n. So this is what we will going to get. Is it understood, this one? Hello? Hello? Now by taking
Yes, sir.
inverse transform, if you take, so this one value 1, so we can represent it as del n. Okay, so that we need to take care. So by so if you take the inverse Z transform for this 2 plus single value 2, so we will going to get 2 into del of n. So that impulse signal. So earlier we have seen that. So the Z transform of this del of n is so 1. So that 1 we can represent it as del of n, inverse Z transform. Okay. So this is what. So the long division method, how we can divide and bring down the power of the numerator, and then we can get the inverse Z transform. Is it understood? Hello?
Yes, sir.
Okay. So now try to do this one and get the result of this one, and you practice it. So x of z, which is equal to z square minus 3z divided by z square plus 3 by 2z minus 1. Now the ROC is half, less than z and less than 2. So now we have to keep it in a mind. So this ROC, then you have to bring the long division method and then convert this into the numerator into the factor which is lesser than this. Then you have to factorize, then get the coefficients a and b, then finally get the inverse transform. Will you do it, this one? So you try to do it in your home. So let's see how many of you get this result. So tell me the results tomorrow. So what result you will going to get. So then I'll, if possible, I'll solve. If you want me to solve, I'll solve this one. Is it clear? So anybody any doubt? So you can try to solve this one. Okay, then we will see that.
So should we divide numerator and denominator by highest power, sir?
Yes, that is meant by how we can able to cancel this power, that you need to see. What factor it will going to cancel this power, that you need to concentrate. That is what we have done here, you can see. So what coefficient if I put, okay, so that this factor will going to cancel. Okay, highest power, that is very important. So that factor you need to find out. So can you tell in this what is the value of that coefficient if I put so that it will going to cancel?
So z square.
No, the value if you put 1, you will
1,
going to
sir.
get z square, right here. Is it not? Z square plus
Yes.
3 by 2 z minus 1, you will going to get like this if I put 1 here. So if I subtract it, it will going to get cancelled, right? So the what is the value, coefficient value? 1.
1.
Okay. So like that you have to solve and get the values, and let's solve by you, we'll see tomorrow. Okay. Okay, so then we'll stop here and we'll continue in the next class. Wait for a minute, I'll take attendance.